Hey everyone, and welcome to today's Explainer. We are diving headfirst into a massive, frankly transformative shift happening in education right now, and it is all being driven by artificial intelligence. Today we're unpacking a really fascinating review by Marvin Starominsky-Uehara, who synthesized 22 empirical studies published between 2022 and 2025. And what's so cool about this research is that it doesn't just look at what AI theoretically could do, it looks at what students and teachers are actually achieving with it right this second. So grab a coffee and get ready, because the data we're about to look at is going to fundamentally challenge how we think about learning.
I want you to think about the last standardized test you took. You probably sat in a dead silent room, pencil in hand, just agonizingly trying to recall specific facts you memorized the night before. But what happens when AI flips the script and starts building the curricula? Is our current model really preparing us for a world where AI is literally everywhere? I mean, when generative AI can comfortably pass our most difficult bar exams and medical boards, what exactly are we testing human students for?
To figure that out, we've got a solid agenda today. We're going to walk through 1. The traditional education trap, 2. Generative AI as catalyst, 3. Real-world student innovation, 4. Measuring what really matters, and finally, 5. The path forward. Let's get right into it.
Okay, Section 1, the traditional education trap. Let's look at the foundational flaw in how we currently teach and measure success.
We are basically stuck in a time warp, facing a massive clash of eras. On one hand, we have the dominant 19th century model, subject-based curriculum. That's where math is locked in one box, science is in another, and history is completely separate, all relying heavily on memory and standardized tests. But the 21st century absolutely demands what we call integrated curriculum. This is where students use highly transferable skills like creativity and collaborative problem solving to tackle complex, messy, real-world problems.
And the real crux of the issue, as the research clearly points out, is that traditional exams consistently prioritize information recall over creativity, inquiry, and real-world application. We're basically spending all our time measuring the exact things that AI can do in half a second while completely ignoring the broader competencies that are actually required in an AI era. Things like adaptability, cross-disciplinary synthesis, and human collaboration.
So, how do we bridge this gap? Section 2. Generative AI as catalyst.
First, let's get a clear definition on the board. Integrated curricula, or IC, are educational models that connect disciplinary knowledge through coherent themes or real-world problems. Now, educators have wanted to teach this way for decades, right? But historically, it's just been a complete logistical nightmare trying to plan across different departments and subjects. Well, generative AI isn't just a flashy gimmick here. It is the ultimate catalyst. It's the engine that finally makes integrated curricula practical for educators to pull off at scale.
By providing real-time assistance with lesson planning, AI totally removes the administrative bottleneck for teachers. And for students, it offers instant feedback and insane pattern recognition across massive datasets. But my absolute favorite part of the research is how it shows AI acting as objects to think with. Essentially, the AI becomes this tireless, conversational partner that strengthens cross-disciplinary inquiry, which is especially huge in STEM and language learning.
Moving on to Section 3. Real-world student innovation. This is where the empirical data gets absolutely mind-blowing.
196. That number is just incredible. In a massive study evaluating over 25,000 students, AI integration directly led to 196 actual student patent applications. Think about that for a second. We aren't talking about essays or multiple-choice tests here. Actually, scratch that, we're talking about tangible, real-world innovations recognized by official patent offices, all generated by school-aged learners using AI-supported integrated curricula. No way, right?
And when researchers look at effect sizes, you have to know that anything over 0.4 is generally considered a really significant educational impact. Well, overall learning outcomes hit a strong 0.572, and critical thinking saw an effect size of 0.632. But computational thinking? It saw a massive 1.104 effect size. That proves AI isn't just doing the thinking for the students, it is profoundly amplifying their own ability to think computationally and critically.
Furthermore, AI is allowing students to produce scientific outputs with way higher accuracy. One study in the review showed that students who used AI to build virtual pH meters outperformed human interpretation by a factor of over 5 times. They are literally doing science better, faster, and more accurately because they had this incredible technological lever right in their hands.
And the sheer volume of output is just staggering. Across the studies, researchers logged over 75,000 student-generated ideas. Students are engaging in these rich, multi-turn dialogues with AI about complex experimental variables, they're refining their designs, and they're applying models to entirely novel contexts. This is hard proof that AI boosts authentic, real-world productivity in the classroom.
So, the absolutely crucial point here is this. If we completely change how we teach, and our students are suddenly producing patents and tens of thousands of real-world ideas, we absolutely must change how we grade them. That brings us to Section 4, measuring what really matters.
Enter the OCI, the Originality and Creativity Index. You can think of this as the brand new gold standard for the AI era. It's a collective assessment framework designed specifically to measure educational impact through interdisciplinary, community-focused student portfolios. Basically, it values collaborative, impactful work over individualized, memory-based test performance. It captures the magic that traditional tests simply cannot see.
Let's break down the 4 dimensions of the OCI. Instead of measuring individual recall of isolated, random facts, the OCI gives teachers a highly structured way to assess what students can collectively design and build. It measures 4 things. 1. Critical and analytical skills. 2. Communication. 3. Collaboration. And 4. Community originality impact, which is basically the actual real-world footprint the student leaves on their community. Now, for the educators watching, don't worry. Implementing this is highly practical. It utilizes student portfolios to document iterative, collaborative learning over time. And crucially, this is the best part, it doesn't require tearing down your current system overnight. It can easily be applied alongside existing subject assessments. Teachers can use local challenges like sustainability or preserving cultural heritage as deeply meaningful tasks for this index.
All right, Section 5, the path forward. How do we navigate the real-world challenges of actually making this a reality?
The literature review is super clear that there are hurdles, sure, but they are absolutely solvable. And notice what isn't the main solution here. We don't need to force teachers to become computer scientists. Success depends far less on deep technical expertise and much more on institutional support. Solving workload requires protected collaborative planning time. Tech uncertainty needs sustained professional development. Assessment consistency is handled by standardized rubrics and peer calibration. And above all, schools have to tackle digital inequity head-on to ensure every single student has access to these community-facing projects.
So, what does tracking this kind of learning practically look like? Well, week 1 might be baseline inquiry. By week 4, you're deep into AI-assisted iteration. And by week 8, it's the final community portfolio delivery. Tracking a student's growth cumulatively across a term like this better reflects the true iterative nature of integrated learning. Honestly, it's far better than a single high-stakes test at the end of the year ever could be.
I want to leave you with a final, really provocative thought today. If AI can now pass our standardized tests, isn't it time we started testing for things AI can't do? As you look at the future of classrooms, keep the data we went through today in the back of your mind. AI is a remarkably powerful catalyst, yes, but it is ultimately our responsibility to cultivate the adaptable, innovative, and deeply collaborative learners that this brand new world demands. Thank you so much for joining me on this explainer, and as always, keep exploring.